Hello viewers, a very warm welcome to all the viewers of Wisdom Jobs. In this video, I am going to explain you some basics about the periodic classification and the periodic table. I mean the short form and long form of periodic table and the different chronological approaches in the formation of periodic table. So before going to enter into this topic, I request you all to subscribe to our channel Wisdom Jobs so that you are going to get so many notifications and notifications about important videos in the exam point of view. And if you are not subscribing to our channel, you are going to miss all these videos. So please do subscribe to our channel Wisdom Jobs. Now let me enter into the topic. Now we have got different elements in the nature. So why do we need classification? First of all, we are saying that periodic classification is the arrangement. Okay, it's basically what? It is the arrangement of different elements based on their periodic properties. Okay, so why should we basically go for arrangement? What happens if they are not arranged? Okay, now if you take vegetables, if you go for a market and if you take vegetables, we don't take one tomato, one potato, one capsicum like that, is it not? So we put all the tomatoes as a heap, all the onions, all the brinjals, all the ladies fingers as a heap. So we classify the type of vegetable and we heap them. In the same way, in the nature also, we have got different elements. So these elements need to be heaped or they need to be arranged as per their physical and chemical properties. So we need to arrange them in a proper order based on their physical and chemical properties. So right from 17th century and 18th century, a constant effort has been made in order to arrange them in the form of a periodic table. So the first and foremost guy who introduced or who tried to explore the opportunities of putting elements into a periodic table form is Dobie-Reiner. So Dobie-Reiner in the year 1817, I feel, he started the process of classifying the elements into different types of elements. Now he basically proposed a theory called triads. So Dobie-Reiner proposed the system of triads. That means he grouped up three elements. Initial grouping was lithium with sodium with potassium. So this is one triad. Next beryllium, next magnesium and calcium. This is one triad. And halogens triad. Halogens are starting with fluorine, chlorine and bromine. This is one triad. So he heaped the alkali metals, alkaline earth metals and the halogens into three element tier or three element grouping, which he called it as a triad. Okay, so what is the significance of this Dobie-Reiner is he tried to identify the similar elements and he grouped them into a common path. So that common path he called it as a triad. Okay, but the main disadvantage of this Dobie-Reiner's way of classifying the elements is that these properties of these elements are a periodic function only up to calcium. Okay, so in 1850s or 1840s, there are around 56 elements discovered in the nature. Okay, so out of the 56 elements, only these nine elements are classified. So how to classify the remaining? We don't know. So then came our Newland. Newland proposed a theory on octaves. Okay, so he proposed a theory on octaves. That means for every 8 elements, that means if I take lithium, lithium's atomic number is 3. So if I add 3 to 8, I will be getting 11. If I add 8 to 11, I will be getting 19. So for every 8 atomic numbers, the same properties would recycle or repeat. That's what is proposed by our Newland. So he proposed a theory called Newland theory of octaves or Newland law of octaves, which states that any element and its eighth element from it have got a similar properties. That means if I take the example, lithium and sodium are separated by an exactly 8 number in atomic number. Okay, so whatever the properties of lithium are there, the properties of lithium are similar to the properties of sodium. So in that way, Newland proposed that every eighth element from a current element will have a similar properties. But this Newland law of octaves could not successfully explain the concept of this similar properties for higher elements. Okay, now it could explain to some numbers, but if you go for the fifth group element and sixth group elements, it could not explain the concept properly. So then came the concept of Mendeleev's periodic table. Yeah, Mendeleev proposed that it's not as per the number 8, or it's not as per the triad, but it's as per the atomic weight. Okay, so Mendeleev proposed that the periodic table should be classified as per atomic weight. So the parameter taken for classifying is that of atomic weight. Now if you take atomic weight into consideration, we have cobalt and nickel. So cobalt has got a more atomic weight, less atomic weight when compared to nickel. So I think it is around 58 and this is 58.3. But actually, this is 58.3 and this is 58. If you observe, the nickel comes before cobalt. So in our today's periodic table, after nickel comes cobalt, but cobalt has got a less atomic weight and nickel has got a more atomic weight. So like this, there are some more pairs of elements where the atomic weight of a prior element has got a more value when compared to its succeeding element. So this is not explained by Mendeleev's periodic table. And one more disadvantage of Mendeleev's periodic table is he actually in the periodic table he actually simply kept some blanks. Okay, so he kept some blanks, and he could not identify all the elements. So as of now, around 120 elements are there in the periodic table, but by the time Mendeleev proposed, they have identified only around 56 elements. So in that 56 elements also, he could not place some of the elements in the correct position which are there in the present periodic table now. Okay, so that's the reason why Mendeleev's periodic table is being scrapped away. And Moseley, another scientist by name Moseley, he came and he proposed that the parameter that is to be taken as reference for classification of periodic elements is not atomic weight, but the Moseley proposed that the parameter should be nothing other than atomic number. So instead of atomic weight, atomic number, which is Z. Okay, atomic number Z is to be considered for preparing the periodic table. So Moseley's law states that the elements in the periodic table are a periodic function of atomic number but not atomic weight as proposed by Mendeleev. So as per Moseley's law, if you observe the modern periodic table, you can definitely see all the elements as per their atomic number only. So Moseley's law is the most useful law in the preparation of periodic classification and periodic table in the modern form. So in the long form periodic table, if you observe, we can see the examples of placing of the elements as per their atomic number. But even in Moseley's periodic table, there is one more difficulty or disadvantage. So if you observe lanthanides and actinides, so lanthanides and actinides, there is no perfect position. If you observe, you are able to see these lanthanides and actinides in the bottom of the periodic table. So there is no explanation of why the lanthanides and actinides are placed in the beneath of the remaining elements. So if you take the transition elements, they are in the middle, D block elements. If you take the P block elements, they are in the extreme right, and S block elements will be in the extreme left. So lanthanides and actinides, where you observe their position, if you observe in the periodic table, they are at the bottom. So why they are at the bottom, why they are placed at the bottom, there is no explanation for that. So Moseley's periodic law has successfully countered many of of the questions, but one difficulty or one disadvantage of mostly periodic law is that there is no explanation of where is the position of why lanthanides and actinides are placed in the bottom. Okay. So with this note, I am going to stop this class, and in the next video, I am going to explain you about some of the periodic properties of different elements based on their position of the elements. Okay. So if you have any doubts in this particular topic, please do express your doubts or queries in the form of comments, which are provided at the bottom of in the comments box section. So whenever we find time, we are going to address your queries and try to answer your queries. So please do subscribe to our channel Wisdom Jobs, and like and share these videos if you find them informative. Thank you for watching.